Good evening, and thank you so much, Dean McKeith, for that introduction. When I hear people talk about me like that, I have a hard time sometimes understanding that that's still me. I grew up in a small town in West Virginia. I feel like if I replayed my life 10,000 times, this is the only one where I get to be the director of the American Academy in Rome, so I feel very, very fortunate. I was extremely moved by the students' presentations and by your inner encounters with Rome. And, grazie maestro. And I would like to encourage all of the students to think about applying in the future to come to the Academy as a Rome Prize Fellow. A number of the Arkansas students visited us. I've extended the invitation to the Auburn students and others. We have artists from every discipline of art, literature, music, visual art, sculpture, painting. We have designers, and we have historians and scholars. And at our table every day, these groups are mixing. And each year we get 1,000 applications for the 30 places, but 30 people have to win every year. So you should apply, and if you don't get it the first time, apply again. What I'd like to do tonight, I've been told I have about 3 hours, and I agreed to finish in 2.5, is just tell you a bit about how I've learned from Rome. And for me, I've always had a fascination with historic structures. This is a staircase built 100 years ago in Pittsburgh. It's made of thin brick. It's about 3 inches thick. It has no steel in it. No building code would let you do this today, and very few people could prove how this stands up. And so I'm inspired by historic structures like this, and everywhere you look in Rome, there are things that inspire designers. We are constantly at the Academy looking forward and backward. This is the Roman god of transformations or thresholds, Janus, who's a two-faced god, and two-faced in a good sense, looking forward to the future, but also always looking backward to the past. And so we're learning from the past simultaneously. Our home, if you haven't visited, come and see us. Returning to the Janiculum, was finished in 1914 with large studios for designers, and founded by McKim, Mead, and White, but particularly by Charles Follen McKim, just after the Columbian Expo of 1893, where McKim, Mead, and White had a neoclassical vision of architecture. If we compare that to Louis Sullivan at the same time, there are some arches and neoclassical elements there, but Louis Sullivan had a fundamentally different vision for architecture. He was really not pleased with the turn American architecture took with the Columbian Expo, and he said it was a virus with a contagion and a violent outbreak of the classic and the Renaissance in the East. This, of course, gives us buildings that we love today: state capitol buildings, grand train stations, post offices, museums. And he says architecture died in the land of the free and the brave, and it'll take a half century or more for us to recover. He was pretty accurate. At the American Academy, we were really gung-ho Beaux-Arts, meaning almost entirely neoclassical, up through World War II. And World War II was such a devastating moment that the director of the Academy at that point said, what are we going to be in the future? And began to reinvent ourselves in a more modern way. And shortly after, we had Lou Kahn, who comes as a resident in 1950. And his architecture changes forever as a result of spending time in Rome. And many of his great designs, of course, don't happen if he's not in Rome. We also have Astra Zarina, who comes to Rome in the early 60s, and she doesn't leave. She founds the University of Washington Center, and which has its 50th anniversary next year. She starts working on preservation of hill towns, having won the Rome Prize, and she becomes an example, I think, of what happens for home institutions when their faculty become so entrenched. I think finally they had to send the provost from Seattle to get her out of the palazzo in Rome. So, and I say this with great respect for what she achieved. Robert Venturi writes Complexity and Contradiction, which changes the direction of architectural discourse internationally while he's here in Rome. And of course, Fay Jones is a fellow in 1980, and I include this tribute to what I think is one of the most elegant details in the history of American architecture, this lovely crossing of the timbers in the void left by the steel plate. I haven't seen the project in person at Thorncrown Chapel, but I hope to get there someday. And so we've had a long history, and now we're very pleased to have the affiliated fellowship in art history, and they've had 2 faculty members coming from Arkansas to Rome, and we hope this is something we can continue to do and continue to build our interactions with the Rome Center. So I'm really honored to be here tonight. And I also have to say we're pleased to have Marlon Blackwell as a resident this year. He's exploring themes of light and dark and mass and void, and he's trying to get me out of the office occasionally, which I appreciate. As I've doing my administrative work, we went and looked at a dome in the north side of Naples, the Temple of Mercury, which is a precursor to the Pantheon. And you can see some of the key elements of the concrete dome of the Pantheon are there with the oculus. And at this dome, I'm not encouraging students to do this, don't worry, faculty. You can actually climb up on top of the dome and look down through the oculus. And Marlon and I, you may wonder if my hand is about to push him in. I'm actually trying to keep him from going in. He acted like he was just going to, go hang off the edge or something. At the American Academy in 1975, it was actually possible for us to take our fellows up on top of the Pantheon. Unfortunately, Rome has tightened up its security for tourists since then, so the director can no longer make a phone call and say, we'd like to go for a wander on the roof of the Pantheon, but those were the days. There are, of course, magical things you can experience with this timeless building. If you go on Pentecostal Sunday, which I think is June 9th this year, you can see the firefighters of Rome dropping rose petals through the oculus. And to see the rose petals fall through the light is something that I think we should all try to see before we die. And also, of course, if it snows in Rome, you have to run to the Pantheon and try to see snow falling through. When it snowed here last year, a bunch of us went down there, and it was too warm inside. And as soon as the snowflakes went through the oculus, they melted. So I think it has to be a proper blizzard for us to see snow. At the American Academy, we dine together in our meals, and one of the magical things that I find about Rome is that wherever you scratch, there's always something under the surface. There's always more than meets the eye. And when I was here as a fellow 12 years ago, I became interested in this very simple ceiling overhead in the cortile of the American Academy building, and there were concerns about small cracks in it, and I discovered to my astonishment that this was thinner than an eggshell. It was about a couple of centimeters thick, and I decided, God bless the Beaux-Arts architects, the width of the cortile is exactly the width of my studio. So I decided to build this in my studio, and I asked some of the art historians who were really excited to pick up a brick because they don't get to touch materials enough, our colleagues in art history. So they helped me, and we built a brick vault in about 5 days, and we built a full-scale reproduction of this vault. So this is a historical technique. It's an Islamic technique that the Moors introduced in Spain. It spreads all over Italy. It's virtually unstudied in Italy, and we find master masons in Rome in 1914 who can build this at the American Academy, and they are now disappeared. You cannot find someone in Rome to build this technique anymore, and you can see it's quite a stunning geometry, and it has reasonably high load capacity. This is a performance piece I call Two Bald Guys and a Hairy Friend. And we invited some chefs up on top as well, and eventually I had to demolish it. The Romans, of course, didn't invent the arch. The oldest arch that I know of is in Egypt, and these are temporary worker sheds that are the so-called Nubian vault. So this is about 1230 BC. And the vault I was just showing you, the Moorish tile vault, is developed in the medieval period. The earliest one we know is from around 1100. We've pushed that back 100 years in Marrakesh. And the Nubian vault is in the center. And the Roman vault has a real problem, which is that you have to use a lot of timber to build the formwork. So if you're in a location in the Mediterranean that doesn't have a lot of wood, you need to find some way to be able to build quickly. And this tile vault was developed and taken to the United States by two immigrants, Rafael Guastavino Sr. and Jr., And they built 1,000 buildings all over the country, including a Scottish Rite Temple in Little Rock that I need to get to someday. So if anyone's there sometime and can get a photo and send it to me, I would appreciate it. Here's Guastavino Sr. He's hired by Charles Follen McKim in 1889, 5 years before the Academy's founded, to build the Boston Public Library. And we've been researching their work, and in early train stations. This is New York's first underground subway station, the Guastavinos build. Here they are, father and son, father on the left, both named Rafael. And they really make their mark and become nationally known in the US through building a large dome at St. John the Divine, where like in New York, where like Brunelleschi's dome, they build with no support from below. So here you see the masons are sitting on the bricks that they laid the day before, and they're building out into space. Completed a dome in 14 weeks. It's the size of the Pantheon. It's only 4 inches thick, 10 centimeters thick. It was meant to be temporary. It's been there 100 years. And if we look, the Pantheon's on the far left, the St. John the Divine second from the right compared to Brunelleschi's dome. And you can see how thin it is, and it's been there for 100 years. So it's a thin shell and brick. And they were way ahead of their time in terms of construction. They also did beautiful, beautiful concert halls, long-span museums, and you can see during construction they had simple guides to guide the form, but here's an oculus closing in, and this is the same vault from above during construction. And in my research on the Guastavino family, I found several hidden figures in American architecture who hadn't been fully appreciated. Julian Abel is an African-American architect who designed most of the Duke University campus, including the chapel, was totally unknown at Duke up until about 20 years ago, and now, 2 years ago, they renamed the main quad after him. He worked closely with Guastavino Jr., and that's an incredible story in American architecture that we're only beginning to tease out. He worked at Horace Trumbauer in Philadelphia, and he was born and raised in Philadelphia, and educated in architecture at Penn. And then Guastavino Jr. worked with Hildreth Mayer, a mosaicist who won the AIA Gold Medal from the Architectural League of New York in, I think, 1930 or so. And they built, together with Guastavino Jr., the Nebraska State Capitol building, 5,000 representations of corn in ceramic tile. It's quite a building and worth a visit, and she's an incredible untold story in American architecture as well, and you can see Native American motifs, a lot of very interesting things that they were doing, and always inspired by the new world, the old world, but trying to invent something appropriate for the new world, which is all of our challenge as we go back to the US. What do we do? The next time you're in New York, the Oyster Bar under Grand Central, you can admire the Guastavino family's work, and I'm usually on this chair, number 2, a few times a year. I'll be there Monday night. And Ellis Island Registry Hall, where thousands of immigrants, millions of immigrants arrived to the US. My great-grandparents from Italy immigrated through Ellis Island in 1921. And when I was studying Guastavino, I saw that there was a panel here that said it was built by the Gustavino brothers. The name was misspelled. It was incorrect. It was built by the son. The father had died. And so here we have one of the most significant landmarks of American immigration built by an immigrant, and the story was totally unknown. And so we've really been pushing on this for almost 20 years, which for me began with a Fulbright scholarship to Spain. I didn't go to Spain to study Guastavino, but I encourage the students to also think about applying to a Fulbright scholarship one day. I have to tell you, Italy is very, very competitive because a lot of students come here and they get a taste for the carciofi, carbonara, and the spritz, and they want to come back. So you could apply to Italy. I'm on the board. I can tell you it's very difficult. But there are many other countries in the world where you can also apply for a Fulbright. I saw the statistics for Italy. I got scared, and I applied for Spain. The odds are twice as good if you apply for Spain. So small tip for the students, think about a Fulbright at some point in your future. And if you're looking for Easter gift for your loved ones, you can get this on Amazon.it in paperback. Now, I want to shift gears toward learning from Italy and toward design. I was studying vaults out of historical interest, but I went to this building. I stood at it in 5 different times. I stood under this vault. I could not figure out how it stood up. And then one day I turned on the news and I learned that, in fact, it does not stand up. This is the Charles de Gaulle Airport. This is a €1 billion failure. It collapsed at about 5 o'clock in the morning. 6 people were killed. It was a calm day. If it had collapsed 3 hours later, we could have lost 150 people or more. And it's a terrible tragedy, and yet, for those of us working in architectural design, you know that it's quite easy to create a curve and then to extrude it into 3D and then to hand it off to someone and have them make it stand up. And that, to me, is a broken way of practicing, and we need to think more carefully about how we're generating form, how we're working with contractors, engineers, how we're thinking about materials. And, frankly, this is a poor form, and we as designers have many analysis tools, but we have very few design tools. So in my group at MIT over the last 17 years, we've been developing design tools, taking inspiration from history, in particular graphic statics, for discovering form. Gaudi's inclined walkway in the Park Güell is not a psychedelic form that he built when he was tripping on acid. It's a deeply rational form that's a soil retainment system. And the form is found through graphic statics. So in a book called Form and Forces, we developed these techniques, and our research students have pushed it into 3 dimensions, and you can download Rhino Vault for architectural students interested in designing vaults, for pushing compressive surfaces into 3 dimensions, and for explaining how things like these insane spiral stairs by the Guastavino company can stand up with no steel, even if the building code says this isn't possible or legal. And I want to bring it back to Rome. We took Pierluigi Nervi's Palazzetto dello Sport and started studying it using Rhino Vault. And I don't have time to go into it, but the images on the lower left, one is the geometry of the structure, and the other one is the calculation of the forces in the structure. It's called a reciprocal diagram. Because it's reciprocal, the image on the left could be the geometry and the right is the calculation, or the image on the right could be the geometry of a dome with an oculus, and the image on the left is the calculation of the forces. So there's a great richness in these methods, and we've been trying to revive them. And I just have to take a little bit of detour into this remarkable building, the Palazzetto dello Sport, because if we think about Rome in the 1950s, it's right after World War II, the Olympics have been awarded. There's a shortage of steel and cement. Pierluigi Nervi develops a geometry using ferrocemento, using bathtubs, essentially very thin. It's basically chicken wire with a bit of mortar around it, and then those diamond-shaped prisms, which are like bathtubs, like little kiddie pools, can be moved by a few guys with a cart. Those are arrayed. These are them upside down on the formwork, and these are them going into place. They're arrayed with reinforcing on top, and then gaps in between leave ribs. You cast the concrete on top, and you get this beautiful ribbed surface. So you get structural depth with very, very economical use of materials. And Nervi had developed this system so well that they built the entire dome in 40 days. And any of you have built construction, imagine doing this with no computers in 40 days in 1957. The Olympics were in 1960, so here's an idea, a project that finishes ahead of schedule and under budget 3 years before the Olympics. Can you imagine that? And Nervi, I want to highlight this aesthetic point. Nervi said that the easiest thing to do was to have the dome go straight across between these Y-shaped buttressing supports. And he said, but that's not natural. That's not the way the forces would flow. And if you have it go straight across, it looks a little more like a Howard Johnson's, or it's a little more of a regular kind of humdrum piece of thin shell architecture from the mid-century. By having this upturned eyelid, Nervi's saying that's where the forces go, and that's the difference of a real master who's trying to demonstrate and articulate geometry through flow of forces. But the diagram for this as a structure is dead simple. It's an arch, and then he rotates it as a dome. So this is an incredible, incredible building. If you have a chance to go see it, Muhammad Ali won the gold medal at the 1960 Olympics. He was 18 years old, and he fought under this. So this is a very historic space. It's threatened as a monument. It may be, its future is uncertain, and for me, it's one of the challenges of Rome is recognizing and valuing 20th century architecture because it seems so unimportant in the big scheme of things. just a little bit about structures class. You all have probably heard the Gaudi hanging models. If you hang a chain with weights and freeze it and invert it, it's an ideal shape and compression. Polanyi applies that at St. Peter's. St. Peter's cracks in the early 1700s. They're really concerned, and they use this system to prove that, in fact, the dome is safe. And this is a problem we have today in understanding historical monuments. The Trajan's Markets, one of my favorite buildings in Rome, incredibly clever use of travertine corbelled brick to minimize the amount that you have to form before you start pouring the concrete. And it's not poured as much as it is placed. You can see the kind of hand-placed Roman concrete. A few years ago, steel bars were put in this. They said after 2,000 years it doesn't stand up. Before I die, I want to remove these steel bars because I always say to my students, if you do a calculation that says the building doesn't stand up and it's been standing for 19 centuries, it's not the building that's wrong, it might be your calculation. And so developing a sensitivity toward how historic buildings work. Of course, in Italy, there is a danger of earthquakes, and it's in Francis and Assisi. There was very sadly collapse in 1997. We lost frescoes, and this terrible moment, 4 people lost their lives, and a much heavier roof had been added in reinforced concrete just a few years earlier, replacing a timber roof. The building had survived much larger earthquakes for 6 centuries, and so how we intervene in historic buildings can help determine how they survive future events. And of course, this is an ongoing saga with the intersection of natural hazards and cultural heritage, which is a major challenge, and I think areas where we can build collaborations as researchers between Italian universities and American universities. And I can't really talk about learning from Rome without saying a little bit more about the Pantheon, and my students and I have been studying and trying to prove that this building is safe under any possible earthquake that Rome could throw at it. And in particular, if we think about the structure with these magnificent relieving arches that allow for openings and voids in the interior, this drawing by my colleague Lynn Lancaster, and the fact that the Pantheon has much lighter concrete in the crown of the dome, it's almost light enough to float by using the pumice stone, the very lightweight pumice stone. The density is almost half at the crown what it is lower down in the travertine and brick sections. And this is more or less what that lightweight tuff looks like. But what many people don't know is the last time the plaster was off the interior, there are cracks all through the interior of the Pantheon that are about 20 centimeters wide, 8 inches wide. They're radial cracks, and the dome is cracked, but it's absolutely stable. Lancaster has studied the geometry of this, and we've been doing 3D printed models to study the stability under earthquakes. And 2 students, Anna and Juanita, a few years ago came to Rome, and this is the shocking discovery that all faculty have when they send students to Rome, is I thought they were going to just have a good time, but they actually did a huge amount of work while they were here. And built a 3D model. We 3D printed it. This is a 1:100 scale 3D printed, and then we tilted it to show that the Pantheon could resist up to 0.5 g, so half of gravity applied horizontally. The maximum expected ground accelerations in Rome are maybe 10 to 12% of gravity horizontally, so this is 4 or 5 times more stable than the largest earthquake we expect to happen in Rome. So if anyone comes and says the Pantheon needs a new jacket made of carbon fiber or steel, we're prepared to stand up and say, please don't touch that building, because it obviously has incredible stability. And I want to close with 4 brief projects and how our work in construction history and historic preservation informs design, and hopefully demonstrate to you that it's possible to really look backward and forward simultaneously. Our first major international project was in South Africa. A colleague of Marlon's, Peter Rich, called us and said, we want to use local materials, we want to use local labor and use passive systems. And so we developed an idea using arches with basic earth bricks, compressed with 7% cement as a binder, so almost all of the materials produced locally. and then using this tile vaulted system to build a series of long span arches unreinforced. So there's no steel. These are stable through their geometry, through double curvature and through earthen bricks. And this project was an exciting chance to bring research into practice, and we built a series of vaults and domes. Apparently there were giraffes walking through the construction site. And in 2009, to our great surprise, out of 600 projects entered, it was named World Building of the Year, and it was a great privilege to work with Peter Rich on this project. And I think, Marlon, you've probably seen the project? No, you haven't been. Okay. Oh, he did. Yes, he's in Fayetteville, I hear. And what I want to point out is that this project, by using local material and efficient use of the material, the amount of embodied carbon that it took to build the project was about 60 kilograms per square meter. As a reference, the London Olympic Stadium was about 4 times that. So obviously we're not going to build the London Olympic Stadium out of earthen bricks, but the idea just to get literacy in terms of the carbon impacts of construction. In the bird's nest, which is quite possibly the world's largest absurd application of steel, you could build 5 London Olympic stadiums for the same amount of steel as the bird's nest, and it's perhaps 20 times as carbon intensive on a per capita basis. So I think we need to gain literacy in these issues. We can learn from historical methods of construction, and Mapungubwe demonstrates that it's possible to build with less. After that project, Norman Foster called us to help develop an additional similar concept for drone ports, small airports in rural Rwanda. And at the Venice Biennale 3 years ago, we built this using fiberglass splines to define 3D geometry. And this is still there in the Arsenale at the end of the Arsenale in Venice. It's been up for 3 years if you have a chance to go see it. It has no waterproofing on top, so I'm always a little worried about it. And Luis and Sixto really took the lead on designing and building this project. And here we are with Lord Foster with a drone inside. And so that was a fabulous learning experience for us as well. And then the final 2 projects I want to share. This project was a deeply emotional project on our campus at MIT. When the Boston Marathon bombers went on the run right after, in the days afterwards, one of the first acts, they killed an MIT police officer on our campus. And they tried to steal his gun. They didn't get his gun. And so my colleague Mi Jin-yoon was asked by the memorial committee, to design a memorial. And she came up with a geometry in granite, large granite blocks. This was one of her initial design concepts. And then using historical ideas from masonry vaulting, we said, well, each leg of this structure needs to have an arch that works in compression. And we developed tools that allowed her team and the whole design team to explore hundreds of different geometries, but always have stable geometries in stone. And then we use 3D printed models to explore construction sequencing. And here you see we're building the 5 legs and going toward the middle. All the tolerance gets thrown toward the middle if you do that. And our challenge was to have the vault be as tightly built in the center. So actually started with the keystone and worked backwards to shed all the tolerance into the 5 legs. And we CNC'd the blocks in Wisconsin with Quora stone. A giant robotic arm with a diamond blade is kind of something out of a horror movie, frankly, but as long as you have a tight control over the console, I guess it's okay. And we were able to get accuracy to within about 1 millimeter in the fabrication, and you can see here's the keystone on the left coming together, all supported on scaffolding. Then we got 3 meters of snow. Every weekend we'd get, this much snow. That slowed us down a little bit, and our German engineering colleagues on the project didn't believe that it would stand up, and they insisted on putting steel pins, which I was not terribly pleased about. But we did a big science experiment where we supported it on scaffolding with bathroom scales, 5-ton bathroom scales under each leg. The pins went in ungrouted. We lowered the scaffolding and proved that all the load got transferred in arching action, so it worked as an arch. Here we are in Rome. Arches work. Stone on stone, if you get the geometry right, it stands. And here's the design team underneath the vault. And here we are at the opening on the second anniversary of Officer Collier's death. This was 9 months from design to completion. With me, Jin Yoon, and Eric Howler. Bob Asmar was the lead stone installer. He was a pretty gruff and serious guy, and one day I got a call from him. He said, "John, I just came back from the DMV. I got a new vanity plate." I was like, "Oh yeah, Bob, what'd you get?" Equilibrium. He believes in equilibrium now. So if you're ever behind a truck with this plate, you know it's the guy who built that memorial. And that was the first time I ever saw him smile, actually. And then, partly as a result of that project, we got invited to the Venice Biennale by Alejandro Aravena, together with Philippe Bloch and Matt de Jong. And it's been a great privilege for me to get to know and work with Kurt Rom. And what a surprise that you have published with Matt's father. You come from the same discipline. This is correct, yes? Matt was my PhD student. And it's been great to be able to build this and strengthen our ties with the University of Arkansas with you. And together with Philippe and Matt, we developed a concept for a 3D vault. We had, in this case, about 5 months start to finish design and fabrication. This is the interior. And we got it down to each stone could be fabricated in 45 minutes. We fabricated it in Austin, Texas with robotic milling. And as the saw blade passed over it and you break off the stone fins, instead of going over it 10 more times to get it smooth, we just left the fins so that we could speed up the fabrication. This is the interior surface. This is a dry stone vault. There's no mortar, there are no pins, there's no steel. It stands purely through geometry. And you can see Aravena arrived, and he was quite interested. And then before we knew it, he climbed on top. We did this with the Escobedo family from Austin, fabulous contractors and fabricators, David and Matt, father and son team, like the Guastavinos. Aravena was standing up there, and he turned to us and he said, "You know, I look at this and I understand everything." And he said, "And then I understand nothing." So we have achieved something that's both simple and complex simultaneously, we hope, out of this vault in stone, Texas limestone. And we're actually currently looking for a home for this. So if any of you have some extra suitcases filled with cash and you need like a new barbecue pavilion for your backyard, this is where Biennale projects end up. So I'd like to close by saying what a fabulous honor it is for me to be here, how important it is for me to continue to strengthen ties between the American Academy and Rome, going into our 125th year, and all of the Rome programs that are often starting with architecture like we did and expanding into new disciplines. And that fundamentally there's so much to learn from history, there's so much to be invented, and frankly the world needs creative young people to work on the tough problems. So I hope I've given you some ideas of things to work on. And for those of you who are going to be here in Rome, we got a whole bunch of things coming up. And you know, we always have healthy supplies of Prosecco with beautiful views over the city, and you are welcome all the time on the Janiculum. Please come and join us. Thank you so much. Buona serata.